Okay, today we're talking about parallel lines and parallel and angle pair relationships. Okay, so in parallel lines, how are the different types of angles related? On 6.0, remember we did that activity where we rotated the triangle and we created congruent triangles. Okay, in that activity, we also created parallel lines. So if you look here in this activity, it's just from my rotating my triangles. So here's my triangle, I rotated it. I rotate it again and again. I've created parallel lines here and here. This is what we call a transversal because it cuts the two angles, the two lines, crosses both of them. So we call that transversal. You can see we color coordinated our angles to show that they are congruent. So these angles, this big angle here is congruent to this big angle. Okay, the green angle is congruent to the green angle. Over here, same thing. This angle is congruent to this angle, and this angle is congruent to this angle. But that also means that this angle and this angle are congruent because they're the same angle when we rotated it. Yes? I don't know if I can. I can do this. Makes this angle congruent to this angle, slightly bigger. Okay? But also means that this angle here is congruent to this angle because when I rotated it, it was the same angle. Okay? So in parallel lines, as a result, you can show lots of angles congruent. So here are our parallel lines. I've numbered them 1, 2, 3, 4, 5, and 6. We are going to color coordinate them. I'm going to draw a circle around it. Move this up all the way up here. That was not fun. Almost there. There we go. Isn't that beautiful? And then we're going to just put here and here are congruent. This and this are congruent. Here and here. You definitely do want two different colors. And then here and here. Okay, if you don't have different colors, find some, borrow some, but it will make it a lot easier for you guys to look at. There you go, sure. Share. You guys have it. You're good. Never mind. Okay. So we have a bunch of definitions and how they go together. But if you color coordinate them, it makes it easy for you to visually see the relationship between the two. Okay. So on this, you just want to review. These are parallel lines. You want to make the little mark for them to show that they are parallel. And this is the transversal. That's what we call a transversal. It's a line that intersects two lines. Okay, the very first thing we have to define is alternate exterior angles. You guys should be familiar with these from Math 1. Okay, but let's review. Alternate exterior angles are angles on opposite sides of a transversal. And outside, alternate means opposite sides. External is outside the parallel lines. And they are congruent when the lines are parallel. The very first one is angles on opposite sides of a transversal and outside the parallel lines. We're writing this down right now. At the beginning of the notes, we'll have a lot of things we need to write down. Okay, so let's look at our picture. We want alternate and exterior. So 2 is exterior angle. It's outside of the parallel lines, like these would be inside. These are on the outside. 2. We want 2, the one on the other line, that is also exterior, but on the opposite side, the alternate side of 2. So what does 2 go with? 7. Okay, because these are opposite sides of the transversal, alternate. They are exterior outside. They're not in the middle, in between the 2 parallel lines. Okay, so 2 and 7 are alternate exterior angles. And because these lines are parallel, they are congruent. Angle 2 and 7. What other angles also have that same relationship? Alternate exterior. Those are interior, inside, but exterior. We're wanting outside. Yep. 8 is outside, and 1 is exterior. They're both exterior angles, and they're on opposite sides of the transversal. So 8 and 1 are also. So write those down. Angle 1 is congruent to angle 8, and angle 2 is congruent to angle 7, because they are alternate exterior angles. Okay, alternate interior angles. Same idea. Angles on opposite sides of a transversal and inside this time. Instead of outside the parallel lines, they're going to be inside the parallel lines. So right here. Angles on opposite sides of a transversal and inside the parallel lines. They are congruent when the lines are parallel. Okay, so let's look here. So again, now we still want alternate, but we want interior angles. So again, we're looking at these ones that are inside, in between the 2 parallel lines. So 4, on the other parallel line, what would 4 go with? 5, because they're on the opposite sides of the transversal. Okay, and you notice they are the same color. That helps us also identify that they are going to be congruent. Okay. So angle 4 and angle 5 are alternate interior angles. And what's another pair? 3 and 6. 3 and 6 are also alternate interior angles in parallel lines. Okay, now we have Same side interior angles. Okay, angle, so same side interior angles are exactly like it says. They're on the same side of the transversal and they are inside the parallel lines. Same side interior angles. Okay, and they are supplementary. Supplementary again means they add to 180. Okay, so if we look here, we're still going, they're inside, so they're still looking at 4, 3, 6, and 5. Yes. Very good. 4 and 6 are on the same side. And notice they don't have the same color. They're not congruent. They are supplementary. Okay? And 3 and 5 are on the other side. Okay, same side interior. So 3 and 5 are also supplementary angles. So we write that down. Okay, angle 3 plus angle 5 equals 180. And angle 6 plus angle 4 equals 180. Because those are same side interior angles. And they are supplementary. Okay, finally we have corresponding angles. And corresponding angles are in the same general area on each parallel line. They are congruent. They're in the same general area on each parallel line. And they are congruent. Okay, so same general area means they're both outside or above the lines on the same side of the transversal. So let's look. So 2, if we look at angle 2, 2 is above the parallel line and it's on the left-hand side. What one would be above the line, above this parallel line, and on the left-hand side? 6. So 2 and 6 are corresponding angles. Okay. What corresponds to 1? On 5. 1 and 5 are corresponding angles. Then if I have 4, which is below the line, 4 is below the line, what corresponds to 4 in the other line? 8. And 3 and 7. Okay, those are all our corresponding angles in the same general location. So write those all down. So 2 is congruent to 6, 1 is congruent to 5, 3 is congruent to 7, and 4 is congruent to 8. Okay, now we're going to go down to vertical angles. Okay. Vertical angles are formed by 2 lines that intersect. They are opposite each other. And are congruent. Okay, vertical angles are formed by two lines that intersect. They're opposite each other and congruent. Let's get some proper capital. Okay, so if I look here at my intersecting lines, okay, again, I'm going to color coordinate. Okay, so my vertical angles here are 2 and 4 because they are opposite each other. And 1 and 3 because they're opposite each other. Does that make sense? So we would say in this case, angle 2 is congruent to angle 4. And angle 1 is congruent to angle 3. Any questions over that? Okay, a linear pair. Now, linear pair is adjacent angles that form a straight line. Thank you, form. Adjacent angles that form a straight line. Okay, adjacent means they're right next to you. The angles that are right next to each other that form a straight angle or a straight line. So in this, oh, and sorry, let's put down, they are supplementary. Okay, they are supplementary. That means they equal 180. They add to 180. Okay, so in this, okay, you can see that here's my straight line. My adjacent angles, the angles right next to each other are 1 and 2. Does that make sense? Yes.
Would it matter, like, if you did like 2 and 3 and then 3 and 4?
They're all linear pairs. Very good. Yes. So you would say the measure of angle 1 plus the measure of angle 2 equals 180. Then you could also say the same thing with 2 and 3. The measure of angle 2 plus the measure of angle 3 equals 180. And we can continue around. 3 and 4, 4 and 1. So you get this, right? Okay. So now we're going to find x and explain our reasoning. Okay, so A We're given two parallel lines cut by a transversal. We want to know what X is and Y. So the easiest way to start that is to color coordinate. So let's color coordinate those. Okay, so what do we think X equals, class? What does X equal? 61. Okay, they're both pink, right? Now we have to decide what type of angles. So I always start with alternate. Are the X and 61 alternate? Are they on opposite sides of the transversal? No. They'd have to be over here and here to be alternate. Okay, one on this side of the transversal and one over here on this side of the transversal. Okay, and we don't have that. Okay, are they corresponding? Are they in the same general location? They're both above the line and on the same side of the transversal? Yes, so these are corresponding angles. So that would be the reasoning. Corresponding angles are congruent in parallel lines. That would be the reason why. Any questions over that? Okay, next one. Okay, again, I'm going to start by color coordinating. Okay, and what does X equal? 119. Okay, they're the same color, so that helps me identify that they are congruent. But now I did name the type of angles. Okay, are they alternate? Are they on opposite sides of the transversal? Yes, one's on the left, one's on the right of the transversal. Are they exterior, outside the lines, or are they inside the lines? Inside. So these are alternate interior angles. Okay. Alternate interior angles are congruent in parallel lines. Alternate interior angles are congruent in parallel lines. Sure. Any questions over that? Okay, next one. Color coordinate. Okay, any ideas on how I'm going to set that equation?
5x minus 3
Okay, this 5x, very good. I have to combine these two. They're not the same color, so they're not congruent. They are supplementary. So you add them and set them equal to 180. So 5x minus 10 plus 55 equals 180. Okay, you're then going to combine your like terms, this and this. That gives me 5x, negative 10 and 55 are opposite signs, so subtract and get 45 equals 180 minus the 45. $135. And then divide by 5. And x equals 27. Okay. Now we need to know our reason why. So again, we look back at the angles. Are they alternate? Are they on opposite sides of the transversal? No. Okay, so then our options are, let's see, same side interior or corresponding angles. So are they the same side and inside? Both inside? Yes. Okay, so these are same side interior angles. And we say that same side interior angles, they're not congruent, are supplementary. In parallel lines. Same side interior angles are supplementary in parallel lines. Any questions over that? Very good. Okay, next. Okay, let's color coordinate. Hey, Adam, how am I going to set this equation up then?
All right, so you do x squared x squared, and then that's 55.
Equals
I
what?
mean, not 50. I'm sorry. Plus 2 or equals. You do something with the 2.
The 2x, right?
Yeah.
So is it equal to 2x or is it adding to x with 2x to get to 180? Okay, what color are these? What color is this one? When they're the same color, what happens?
Same.
They're equal. Okay, opposite colors are going to add to 180. Same colors are going to equal each other. So x squared minus 63 is going to be equal to 2x. Okay, this is a quadratic equation, yay. Okay, it has an x squared and an x. Okay, if it has an x squared and an x, then I set it equal to 0. So I'm going to move the 2x over. I'm going to get x squared minus 2x, I'm going to write it in standard form, minus 63 equals 0. Now I'm going to factor. Okay, so this is x squared, this is negative 2x, and this is negative 63. However you know how to factor, you factor. Okay, because you do it differently than I do, and that's okay. Are we okay? Okay, we're back up here, class. It was just a sneeze. Okay, x times x is x squared. What multiplies to 63? 9 and 7. So 9 times x is 9x. X times 7 is 7x. Okay, if I subtract, okay, very good. The 9 needs to be negative to get the negative 2. The 7 needs to be positive to get the negative 2. So my factors are the x plus 7, and we set it equal to 0. And then the x minus 9, and we set it equal to 0. Then we solve, we subtract 7 from both sides, and I get x equals negative 7. I add 9 to both sides, and I get x equals 9. Now we need to check those answers. If I go back to my original problem, and I plug x in. So let's start with plugging the 9 into the 2x. So 2 times 9 is what? 18. Can an angle measure 18 degrees? Yes, so we're good. That one works. Let's go to negative 7. 2 times negative 7 is what? Negative 14. Can an angle measure negative 14 degrees?
No.
No, not in this scenario, okay? So this is what we call an extraneous solution. It doesn't apply to this scenario, okay? So our only answer is this. You always have to check your answers within the contents of your problem. Okay? Okay, even though I solved it and get 7, it doesn't apply to this problem. Look at 2 times negative 7 is negative 14. Can I say the angle measures a negative? No, so that's why it doesn't apply here. So 7's not going to work because it gives me a negative length. Then they both would work. Then you'll have 2 answers. Okay? Which one? Yeah, that one, because when you square it, it's going to automatically make it positive. Okay. In this case, it would also make it negative because this would be 49 minus 63 would still be a negative number. Okay, but so that's, yeah. But yes, you want to check it. Okay, so now y. What type of angles are those? Okay, are they alternate? Are they on opposite sides of the transversal? No, very good. They are corresponding. They're in the same general location. So that's the reason why. Corresponding angles are congruent in parallel lines. Any questions over that? Okay, next one. Okay, E, I want you guys to do E. Okay, set up your equation. Shh, okay, we're back up here. Okay, Toby, how'd you set up the first one, E? How'd you write the equation? Oopsie. Plus. Can you wait till we're done with the notes? Okay, 2x minus 8 plus 48 equals 180. That's how we should have set it up. We're going to combine our like terms. Negative 8 and 48 are opposite signs, so we subtract them and get 40. We subtract the 40 from both sides and get 2x equals 140. We divide by 2 and get x equals 70. Okay, can somebody name those angles for me? They're a linear pair. Okay, linear pair equals 180. A linear pair equals 180. So if you go back up here to our vertical angles, that's what they look like. 1 and 2 are like the same ones we just did. They form that straight line, that straight angle. So they add to 180. Okay, next one. Adam,
Yes.
how are we going to set this equation?
Right. Plus 24.
Mm-hmm.
And then.
Mm-hmm.
Okay, so then plus 3x. Plus 48.
If I color coordinate them, okay,
All on the same side.
they're an alternate sides of the transversal, but exterior. So those are congruent to each other. Okay. They're alternate exterior angles because on the opposite sides of the transversal and outside the parallel lines. So then I'm going to put a line down the center and I'm going to subtract the 3x, move my variables to one side. Then I'm going to move my numbers to the other side. 4x minus 3x is just x. 24 minus 24 is 0. 3x minus 3x is 0, and 48 minus 24 is 24. So x equals 24. Okay, I already gave you the reason why. The reason why is alternate. Exterior angles are congruent in parallel lines. Any questions over that? Okay, now they're going to ask us, are the following lines parallel and why? Explain. So in G, we want to prove those two lines are parallel. Yes? Yes, sorry. Is that good? Okay. Next. G, we want to prove the following lines are parallel. How do I know they're going to be parallel? I need to prove some of my angles are congruent or supplementary. And there's more than one way to do this. Yeah? Okay. Okay, what else do I know about these lines and these angles? Okay, so I don't know these are parallel lines, so I can't say anything is congruent yet. Okay, but I do have vertical angles here. Oh, yeah? Okay, so let's just check that. I would need this angle to be 49. So I can say that that's a straight angle, that this is a linear pair. So I'm going to label this X, and I'm going to say 131 plus X should equal 180. 131. Okay, class. Hear a lot of side conversations. Okay. So these two should add to 180 because they are a linear pair. They form that straight line. Okay, so that's the first thing. Reasoning is linear pairs equals 180. So I'm going to subtract the 131, and I'm going to get X equals 49. Now I can say that those two angles are congruent, right? Okay, so that means the lines are parallel. Now we need to name those types of angles. Okay, so what type of angles are these two angles? This one and this one. They are corresponding angles. Okay, so those are corresponding angles. This would be if the corresponding angles are congruent, then the lines are parallel. Any questions over that? Okay, the next one, they want us to prove DC is a mid-segment. Okay, remember a mid-segment? We can prove this, yes. We're gonna skip that one. We're just gonna go here. Yeah, that's fine. We're not gonna go back to it. Because we're gonna do the next one, correct. Okay, can you prove DC is a mid-segment? Okay, so remember mid-segment, we know two things. We need to prove one or two things. Either that this piece is congruent to this piece, and this piece is congruent to this piece. Okay? Or by proving these lines are parallel. Okay, that's the mid-segment theorem. If the lines are parallel, then I can say those are mid-segment. Okay? So can I prove that DC is parallel to AB?
Yeah.
Yes, I can, right? Okay, so I can say that DC is parallel to AB because I have these angles. And if you see, if this is hard for you to see, you can maybe extend those lines to make them parallel lines. And this is the transversal for it. And what type of angles do we have there if we extend those? Corresponding, okay? They're in the same general location. They're on the same side of the transversal, both above the line. So here's the line, it's above it. Here's the line, it's above it. So that's the reason why is if corresponding angles are congruent, then the lines are parallel. Okay, the next step I have to do is what I'm trying to prove. DC is a midsegment. DC is a midsegment of triangle AEB. Okay, and because, remember we just talked about this, because it's talking about the midsegment and the third side of the triangle, that's the midsegment theorem, not the definition of midsegment. The midsegment theorem. Any questions over that? We're good? Sorry, I'll let you guys write it down. Okay, next. Almost done, guys. Okay, next, we want to prove that P is perpendicular to R. They gave us that P is perpendicular to Q. So here's P is perpendicular to Q. Okay, and Q is parallel to R. So this is parallel to this. Okay, so we're going to start with that first thing they told us, that those are perpendicular. Yes.
I was gonna say, so basically, shows that they're perpendicular because
Mhm.
the top line is perpendicular. Not the bottom.
Yes, we have to prove that though. Okay. So we first really need to understand what perpendicular means. What does perpendicular mean? Right angles. Very good. So we want to say, I'm going to label these 1, 2, 3, 4, 5, 6, 7, and 8. So it's easier to talk about the angles. So angle 1, 2, 3, 4, 5, 6, 7, and 8. Since I wrote in on 2 that it's a right angle, I'm going to say that angle 2 is a right angle. So step 1, angle 2 is a right angle. The reasoning is the definition of perpendicular. Okay, step 2, I want to say something about the parallel lines. Because they're parallel, what other angle is going to be a right angle?
6.
6. Okay. There's more than one, so you can name another one. If you didn't see 6, you might have seen a different one. But I can say that angle 6 is a right angle as well. Okay, because 2 and 6 are congruent. But what type of angles are 2 and 6?
Right.
How are they related to each other in parallel lines is what I'm talking about. They are both right angles, I just said that. But how are 2 and 6 related because they're parallel lines? They're corresponding. Okay? Remember, it could be alternate interior, alternate exterior, corresponding, or same side interior angles. Okay? So in this case, 2 and 6 are corresponding angles. Okay? And corresponding angles are congruent in parallel lines. Okay, step 3 now. Now that I've said that this is a right angle, I can now do the prove, which is that P is perpendicular to R. Any ideas on why I know that? Yeah? Very good. And that's what the definition of perpendicular line is again. So I'm going to use that reason again. It's what the perpendicular lines mean. It's the definition of perpendicular. So if 6 is a right angle, then those lines that intersect have to be right, perpendicular. He said that if I have a right angle, then the lines have to be perpendicular. Okay? Because perpendicular lines form right angles.
So because of the right angle on top, the right angle.
There's a right angle on top because these lines are parallel.
Oh.
I mean, sorry, these are perpendicular because they said there's perpendicular. 2 and 6 are right angles because these lines are parallel, and those are corresponding angles. So now I can say that that Q is perpendicular to R. Sorry, that P is perpendicular to R. Any questions over that? We're good? Okay.